Good morning and welcome to Race Industry Now, the weekly webinar series from ePowerTrade, presented to you by ARP, Performance Plus Global Logistics, Peak, Feria Racing Component, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of ePowerTrade, the racing industry, every minute, every day. This is episode 454. And we're going to be traveling to England to talk with Jenvey Dynamics. With me this morning are Judy Keane, the co-founder of ePowerTrade, and a wonderful host, superstar NASCAR three-time crew chief champion, Mr. Jeff Hammond. Judy?
Well, that's a mouthful. So thank you, everybody, for joining with us today. I know we have a lot of new attendees joining Jenvey, and we're going to be sending you login information afterwards just so you have access to this platform. We really put a trade show online. So buyers, attendees could go on this platform and reach out to suppliers just like Mike Jenvey is on here. So look out for that email. Jeff?
Good morning, Francie. Good morning, Miss Judy. And I'm excited about this. Really interested in what he's going to be bringing to the table because this is something that I know a little bit about, and I want to know a whole lot more about it when it's all said and done. So thank you for the opportunity, and good morning from United States to our friends over in England. What's going on there, Ms. Genevieve?
Yeah, good morning all. Good afternoon if you're over here as well. So yeah, we're all good and looking forward to our conversation.
Well, let's get started and let's go to the basics. I mean, tell us a little bit about your background, and what success you've had, and give us an overview of what you're, like they always like to say with me, they talk about my experience. What is your experience in the motorsports industry?
So, I mean, I started engineering from a very young age. So I was rebuilding motorbikes at 7 years old. The company was founded in 1987, and I actually built a lot of the very early throttle bodies in my year after finishing school and then before going to university. So I was involved in the company in those early days as well. From there, I then did an engineering degree at Loughborough University, and did then 10 years powertrain development at Ford Motor Company here in the UK. It's probably I was very involved in motorbikes, and then probably early 2000s when I moved from motorbikes to motorsport. Motorsport's in the family DNA anyway. So yeah, bought a car early 2000s. And from then on, we've always developed our own cars. So the first car was a Formula V, and we won the championship in our third year of racing. So it was 04 and 05. Then we bought a Sports 2000 car. I think you have very similar series in the US as well. And thankfully won that championship again, developing the car, won that championship in 09 and then 14. And then we've taken that Sports 2000 car and we've I guess pimped it. It's now 300 horsepower up from 200 horsepower, big slicks, big wings. And it's basically a development tool now for Jenvey Dynamics. So we run our new prototype throttle body systems on it. We run swirl pots, fuel pumps, different injectors, different linkages, electronic throttle, etc. So it's been with me from the early age. I'm very lucky to have been very successful. So I think last time out we had win number 76. So hopefully I've been able to take some of that into the business.
Well, sounds to me like you've got a very much a storied background, but a very firm foundation to be kind of building on what you guys are taking and undertaking today. And looks like your timing is, as they like to say in our world, is impeccable as far as this is the time the rest of the racing industry, the world is really going through that transition to finally, and anybody that's a motorsports lover, don't take offense to this, but to move into the modern age, get away from carburetors, get into injection stuff and throttle bodies. I mean, get I guess the best way to put it, get modern, get caught up with the times.
Yeah, I think so. I think it's we've seen good growth. I mean, the company, we've been making throttle bodies since 93. So we were quite early adopters, and we've seen the market grow definitely in the UK and Europe, and now we're seeing it growing in America as well. So yeah, it's very exciting. We're lucky in that time we've been able to supply already into World Superbike, British and World Touring Car, R200 rally cars, as well as a number of OEMs and race car manufacturers as well.
Okay, let's break it down here a little bit, and talk to us about electronic, fuel injection. Talk to us about throttle bodies as a whole, and making sure that we understand there is a difference in the two. I mean, there's what the application calls for, and at the same time, how do you differentiate, and what's the benefits?
Okay, so Jenvey Dynamics, I've got some parts to show you here. So firstly, we'll just talk about what a throttle body is. So a throttle body is essentially just a valve to control the airflow into the engine. So as you press the pedal, it opens the throttle, and obviously more air flows in and you get more torque from the engine. With the electronic throttle side, obviously you then have on the throttle bodies items like fuel injectors, fuel rails. We have a throttle position sensor to feed back into the ECU. So here at Jenvey Dynamics, we work with, I guess, with all the ECU suppliers. All our products are kind of generically compatible with the ECU suppliers. So whilst we don't supply the electronics as such, we supply all the hardware that's going to get that air and fuel charge into your engine.
All right, so the key thing right now would have to be, we understand the principle of it, but what can you do, as from your vantage point or whatever, to make your product better than anybody else's product out there? Because I understand the throttle body concept based off of my time here working with the NASCAR Craftsman Truck Series, and everybody pretty much runs a standard throttle body, and everything is governed so much by the electronic ignition or brain, you might say, in the deal. How does all this here come together to make it make sense to us? How can we say, or how can you tell me what you're offering me is better than my competitor?
Okay, so let's start off. So we've obviously been manufacturing throttle bodies for a number of years. It's been a continual over 30 years now. It's been a continual development process. So we have a few things. We have a very extensive standard range of throttle bodies, and within that we've spent a lot of time refining them, and the refining is in terms of choosing what tapers and what sizes work best for different engines or different airflows. I've got a few standard products to show you here as well, I think what I'll do, I've got a few standard products to show you, and then if it's okay, I can sort of lean into a presentation we've got that'll kind of give you a bit more detail on designing your system to win races, essentially. So as I said, we've got a fairly extensive standard product range. So it starts with our Motorsport DCOE throttle body. So that will fit in place of a Weber or a Dell'Orto, and it'll fit directly onto those manifolds. Although we always warn people that obviously all the Weber and Dell'Orto manifolds, they have to run flat for the float bowl, whereas fuel injection throttle bodies can run literally at they're angle agnostic. They don't mind where you run them. So we do the DCOE range, which goes down to, we also do very short ones as well, 30 millimeters. So that we kind of call our base range, typically used in kit cars, where people are doing a large number of engines for a specific series. From then we have our pure motorsport range, which are the single bodies that I showed you before. So these will typically, we do from 28 millimeter up to 60 millimeter in that range. So those are kind of our motorsport bodies, and we can machine those to any size the engine builders want. And I'll discuss about the sizing in a minute. We then have an interesting new product for us in the last few years has been what we call our heritage throttle body. So it's a DCOE flange designed to look in keeping with your classic car, but within that we have all In fact, all the injectors are hidden away inside the body. The fuel rails integrated into the lid. So when it's together, it hides all the electronic side. All the wiring comes out on the underside. So you can tuck that all away. So you can end up with a car that looks in keeping with period, but obviously performs with all the benefits of fuel injection. Typically, those are less motorsports, so predominantly road-based. We do, I guess, a fairly vast range of standard kits. That's an example of, that's actually a Ford Pinto kit using our standard SF bodies. And then we do a vast range of accessories that go with those, such as the linkages, different injectors, throttle position sensors. We do a wide range of trumpets, so we can choose any length of air horn. And all these, as I'll explain in a minute, all these are made in-house. So we have our own foundry, we do all our own design work, and I'll talk to you about that in a few minutes. So that's kind of the standard range. Within that, we've spent a lot of time developing. So for example, our spindle is a very low profile spindle. So it presents a very, very low blockage into the airflow. We also we're very careful with our bearings. The springs are obviously thoroughly durability tested. And especially with the advent of electronic throttle, it makes testing these products on the bench very easy, because you can just leave them running for a couple of weeks and they can do 2 million cycles and you can determine any issues.
Wow. Like I say, that's impressive right there to have a durability test that's that extensive. And by the time it's all said and done, you probably got a pretty good mapping of what your fuel flow, air mixture, and everything like that goes right along with it.
Yeah,
that would be invaluable to folks that are trying to build the power plant, and then the guys that are trying to maximize everything. When you get into this, I mean, you've got so many varieties that you can, pick and choose of what you are trying to assist. Any challenges that you run into? I mean, and again, I'm just strictly using the challenges that I've run into here. And number one is fuel pressure as it pertains to the rails, and then also airflow as it pertains to, where you're picking up, your air to get to make the mixture, or, make the injector work correctly.
Yeah. So I think what's best, I've got this short presentation. Perhaps I go through that, and you'll see my last slide is perhaps the big slide that expands all the theories, and that'll kind of answer the question you've just given. So I will try and share.
Before we jump off into that, talk to us about a little bit about, all the things you've created, and the direction that you find yourself moving in. Where do your company, do y'all have do y'all do dyno testing? Do you do, racetrack testing? And where do you do, I guess you might say, where do you put the product into the performance area to gain the knowledge to know where to go next?
So a few places. One is, the first thing, we recognize we're not engine specific experts. We're not experts in, we actually have very good experience of the Ford Duratec 2 litre, but outside that, we're not specialists on any specific engine. We're not specialists on the Porsche Flat 6 engine, which we do a lot of kits for. So where possible, we try and work with experienced engine builders, and that's really always our first point of call. That said, obviously we do. So the car I race has a 2 litre Duratec, so that's a great learning tool for us. So it did all the early development of our electronic throttle actuator, which I'll show you one later, but we have a standard electronic actuator that will operate all our standard kits. So after the bench testing of that product, that straight away went onto the race car, where it gets shaken up, it's hard bolted to the engine. It gets shaken around at 9,000 RPM, 9,200 when I'm feeling brave. And it gets all the heat cycling, and it goes through all the challenges and the troubles, and really the same with the rest of the system. So we obviously have a lot of kits out there. in terms of the initial development, we work very closely with engine builders. Sometimes we're doing specific kits for them. Other times we're just working with them to develop one of our standard kits that can sit on the website and be purchased, and will just work on most engines of that type. We're always working on airboxes and filtration and where to take air from. Obviously, we always advise people to take the coldest, best prepared air possible. It's very rarely actually achievable to do that. So it's always a challenge of where you take the air from. Can you take it from the engine bay where it's hot air? So in the race car, obviously we force feed air into a very large air box. And it's nice air, and it's taken out. It's not taken off the track. It's taken from a nice cold area. So that makes that side a lot easier. But again, yeah, it's for us that us using our own product is quite important. We have another road car that runs throttle bodies, so we get to run these things every day. But obviously behind that now is also this 30 years of experience. And challenges along the way, and developing too far, and going too far the wrong way, especially with regards to weight. We're always working to minimize the weight, and sometimes we go too far, but that doesn't come out to you guys, don't worry.
Okay. When you talk about choosing the place to get your air supply from, and you talk about hot air versus cool air, is there a break point there that you see? Is it 10 degrees, or what is it as far as when you see it affect the performance of your product, when you're working with it?
Hard to say, and obviously varies on different engines. So once you start going into turbo engines, then obviously that becomes a whole different ball game, and you're generally running higher temperatures, and then the challenge becomes even higher. Generally, in most cars, we see once they're actually running and they're on the track and moving, the problem's often less than people think it will be. I think the bigger problem is people trying to take the air from an area of vacuum. So they're already taking it from an area of low pressure. We're just giving the engine more to do to suck it through our nicely designed system when you're taking it from an area of low pressure. So it's always important to consider, and it always links into these challenges of packaging your complete intake system.
All right, so you've got a presentation for us?
Yes, I'll just bring that up on my screen now.
All right, well, I want to do, while you're doing this, I want to remind all of our participants that you are available for questions during this webinar, and that if you have those, please go ahead and send them over, and we'll give you an opportunity to do that as you're bringing up your demonstration.
Can you see that okay?
Yes, sir. I see it. I do.
Okay. So just an intro screen. So I spoke a bit about the history. I'm just going to talk very briefly about what we do now. So obviously we're innovating, design, developing induction systems, very extensive range. I guess beyond that, we also consult on and develop bespoke induction systems. And we've done that for, I guess, tier one engine suppliers here in the UK, where we can offer fast and flexible prototyping as well. And I'll explain why in a minute with the information about our facility. We supply to a lot of niche vehicle engine manufacturers, and then also professional engine builders. Customers include Radical, Motorsports Cars, Caterham, Motorsport, SCCA Enterprises, and Singer. And just so people are aware, we sell direct via our website and also through distributors, but we're always on the lookout for US distributors, often who are engine builders who use our products or would like to use our products, but then expand into other areas as well. Just about our facility, it's a bit of a joke at the top, but we're always asked, do you really have a foundry? And we really do. So we'll start with the picture on the top left. We have 4 seats of SolidWorks. We have our own foundry, so we create all our own foundry tooling. We have a components area who fabricate fuel rails, levers, and all the small parts that go with the bodies. Fairly extensive machine shop, which is, I'm pleased to say, pretty much full of Haas machines, as well as an assembly area, so clean room for assembly, and then also stores where we have a large stock range, as well as making the bespoke parts. So now I just wanted to really go into the heart of the matter in terms of engineered to win, reliability and quality. And this, sorry if this re-answers some of your questions, but yeah, we've been making throttle bodies for over 30 years. Core design for major components has been refined and refined over time, and every set of throttle bodies that leave the factory are tested before they're shipped. We are always running durability tests, and this is made easy with electronic throttle, where we can just you know, if you have any concerns about springs or anything, we can just hook a test rig up and set it off for however long it may be. Again, working with many leading engine builders, they're always very good at feedback, which obviously improves our product all the time. We're able to offer fast turnaround of customer products, primarily due to having our own foundry on site, and please say we've got fast shipping to the US. We spec system for a number of series, including UK Sports 2000. And as I said before, we race our own products. Our internal quality statement at the factory, which is up on the walls everywhere, is that all products that leave this factory are ready to fit and win races. And that's something we firmly believe in terms of being ready just to fit without any rework, and then being ready to be reliable straight away. Spoke about weight. It's always my what I feel is the most important aspect of winning races, or the first and easy one is to have minimal weight. And even if you've got a weight limit, is to put the weight, choose where to put the weight. So we consider weight very carefully in all our designs and all our products. We're always challenging design. Most of our accessories share mountings, so we don't double up. We see a lot of products where they put lots of bits on the casting or on the product to fit another part onto it. We try to reuse the same mountings all the time. And we love multifunctional designs. So for example, we have a swirl pot, which we include the high pressure fuel pump, the swirl pot, air bleed, and pressure regulation all in one unit. And then we're very focused on ensuring all our lightweight castings come out of foundry lightweight and then are machined to be even lighter. Got a bit about system length here, and I guess this is where it starts getting, we start getting into the heart of it. So we always tune the systems. You can tune them essentially to move around where the peak torque curve, the peak torque occurs. So essentially when the valve opens, there's a low pressure pulse which moves up the induction system to the end of the bell mouth. It's reflected as a positive pressure wave, and you want that wave to then arrive at the intake valve just before the intake valve closes. So this way you can actually tune to suit different tracks or to suit specific engines. Obviously, it's linked very much also with the valve timing and exhaust primary lengths. So I know there's software that can do all of this. We always find we spend a bit of time on dyno just refining those last lengths and just getting the torque curve in the right place. The example I've got here is actually of the Ford Duratec system, which is just showing that the important bit is the length all the way from the inlet valve, or from the entrance to the bell mouth to the inlet valve. And then that gives us all ability to move our peak torque and hence peak power around as well. We do a lot of work with inlet shape. We always favor a consistent taper, essentially from the bell mouth, and you'll have to excuse the steep lines at the beginning. They show where the bell mouth is, but that would actually be an exponential curve. But we then try and have a very consistent taper from the bell mouth all the way into the back of the valve. So the air is always being channeled down nicely. Where we can, that's a complete straight shot into the exhaust valve. So on our Duratec kit, you look down into the bell mounts and you can see the valve. There's no curves, there's no major changes of profile as it tapers down into those valves. We have most of our standard kits have a standard taper about 4.5 degrees inclusive, so that's 2.25 degrees per side, and we found that to work very, very well. Got a bit of butterfly size and position. So from our side, the further we can move the butterfly away from the valve, the better. Especially when you're injecting near the butterfly as well. So you can pick up turbulence from the butterfly, which better allows the fuel mixing. I know there's a slight argument of saying if you've got the butterfly very close to the cylinder head, you get better response. We haven't found that specifically. We find we get much more power from moving the butterfly further up the system. As I said before, we've kind of very careful attention to the spindle and the butterfly shape to make sure there's a minimal port blockage. And then we also have quite a fine shut angle, so you get good throttle control at small openings where it's often tricky to control. Injector position is something that often comes up. So where you've got control of the injector position, firstly, the further back from the valve, the better. Not always great for low-speed drivability. If you look on a lot of production engines, they will actually have the valve, perhaps before GDI, but they'll have the valve, they'll have the injectors in the cylinder head. And that's very good for emissions because you've got very fine control, very small amount of wall wetting, i.e. the fuel is going exactly in the same place every time. But it's not good for performance. You don't have enough time to fully mix the fuel and air. All our standard bodies inject just ahead of the butterfly. And this is, as I said before, to pick up the turbulent airflow from the butterfly to better mix the fuel. And this is definitely a big effect at small throttles, low openings, but also we feel it has quite a big effect at full throttle as well. And that's why we've predominantly stuck with butterflies as opposed to other throttle body systems such as slides or barrels. We found very good results running the injectors much higher up. So in the case of the profile system we have under development on the race car now, we use the injectors closer to the head, which you can see on the diagram, 89mm back from the cylinder head face. They are used for the low speed startup and idling. And as soon as we're above 4,000 RPM and about 40% load, everything is then done on the rearward injectors. And we've actually been through we actually tried on dyno running 20% on the closer injectors and 80% on the rear. And we found better results just running 100% on the rear injectors. And that switching between those two injectors was for us the best part of a 10 horsepower gain. There's a few other bits of things we did, so we can't be 100% sure, but it gave us, we had a 10 horsepower gain and we felt most of it was due to that injector position.
Okay, before you move on too very far off of that, I've got a question from my little pea-picking brain here. All the things that you're saying, when you're talking about the horsepower gain, are we talking about horsepower gain strictly at the top end, or how do you determine it? Because you said, moving it up and down away from the valve and the things that you have been working through, is it the shape and everything? Does that affect you at low speed? You're like going around through a corner and you're looking to accelerate and you get momentary, hesitation or stumble before you get it going again.
Yeah.
And that gain on the horsepower, is it more on the top end? And in my mind, I'm wanting to make sure I'm following everything correctly.
Okay. So I guess that it's easy to focus purely on the top end. And And one example on the race car, obviously six-speed gearbox, paddle shift. You're always in that top end, but these things do affect the low down as well. So in terms of, as we spoke about the tuned length and the overall length, you can get a dip if your peak power is at or peak torque is at, say, 6,000 RPM. You might find there's another peak at 3 and you get a slight dip at 4.5 in between the two, where the pressure wave is working against you, not for you. What I would say is, obviously with fuel injection, that the one of the big advantage you have is you're able to, where you get rich areas where the tuning isn't working correctly, you are able to map that electronically to get the fueling correct. Okay. So generally you can minimize these dips. They'll always be there, and then that's part of your decision about what overall length you want, is where you want the peak and where you can handle a dip. And obviously that depends on a lot of the other factors.
Okay, well, thank you on that. Appreciate it.
No problem. I'm trying to think if there's any more to that. So, you know, things like the rearward injector, we were still producing more power on the rearward injector. It's a 2-litre 4-cylinder engine. It's 9,000 RPM, about 310 horsepower. So that's for from the UK side. That's a very strong club motorsport engine, let's say. And we were still producing more power on the rearward injector at 4,000 RPM. We didn't go below that because we've got 4 to 9 where we've got this good and we're able to map it correctly. So we were happy with that. But as I say, you can, you know, I raced Formula V for years, where you run carburetors and it's one carburetor in the middle linking the two sides, and the challenge was always where you want your, not only where you want the peak power, but where you want the dead spot to be, because you always had a dead spot. So in mine, I think that the Formula V, it revved in the end to 7,500 RPM, but it did nothing at 4,500 RPM. So then you just had to slip the clutch and muck around to stay ahead of everyone out the chicanes.
No, that's exactly what I was talking about. Thank you again.
But with fuel injection, and we didn't get the chance to fuel inject that engine, you would have been able to map a lot of that dead spot out. Obviously, what was happening was it was pulling the mixture in, then sending it back out and pulling it back in again. So running extremely rich at that 4,500 area. And obviously with electronic fuel injection, you can put that under dyno, or it can self-learn, and it would learn and correct that fueling to be the ideal fueling. So essentially it would pull a lot of fuel out. So you were putting less fuel in, and as a result, you would have seen much less of a dip. Okay, so we're nearly there. So those are kind of the main subjects. I guess I just wanted to say other items that have a big effect, and you alluded to it earlier, is clean air. I should have put clean and cold air in. Very important to get your filtration in your airbox right. We see people with a wonderful length system, and then the filter is right onto the ram pipes, which effectively reduces the effective area of the ram pipe. So you try and have, we say, at least 2 inches space between the ram pipes and any filtration or airbox. Always try and take it from a cold, high pressure zone. The electronic side, us throttle bodies have worked with all ECUs, whether it's Motec or Life or some of the UK based ones, Link, etc. They work with everything. In injectors, we try and get the sizing approximately correct. I don't sweat too much over it. We just put a little formula in there we use for horsepower in the UK. cc per minute equals the horsepower you want to achieve times 1.75 times the number of cylinders, and that's just a safe, gives you a 20% leeway on injector sizing. Then we have a whole range of different throttle position sensors, which are obviously required to then set the fueling in the brain, contact and non-contact ones. And then also we have mechanical linkages and we have electronic throttle. And electronic throttle's come along recently and has been a very good, a great innovation, because now we can open the throttles when it's cold for fast idle. We can do auto blip on downshift. It just helps start, it helps controlling. We can limit the throttle you said about low RPM and achieving the best power at low RPM. Sometimes, let's say on my engine at 3000 RPM, it's not, you don't want full throttle, you want about 40% throttle, because then you get good mixing. So that's that. And I guess my caveat to all of this is there's a problem, and that's nearly always packaging. Some race cars, formula race cars and sports prototypes, we don't have a problem. A lot of cars in between that we do. So this is our standard Honda Civic Type R EP3 kit, where people want to keep the standard water housing, so you have to run a very dog-legged manifold to fit around the water housing, and then unfortunately the rest of the car is in the way as well, so you've then got to run an extremely short system to fit it in the car, and this compromises all the good stuff we've just discussed. So sometimes you have free reign, you can do what you want, but other times there's a discussion and a bit of design and development around where the compromises are going to come in to get it to fit in the car. And that's the end of the presentation. I shall stop there and there. That's just on there. That's LS electronically actuated V8 kit that we do.
Okay, very impressive. The one other question I've got, when you do your injections and all the stuff, throttle body, is it all pretty much all aluminum casting, or is it some kind of other exotic metal that you make some of these things out of?
At the moment, we just do aluminium.
Mm-hmm.
So we actually use a very specific aircraft grade of 2L99, which is a standard automotive aluminium. We use a very specific grade of that. So essentially our castings are fairly, when I say soft, they're not soft to touch, but they're not brittle, which is always a problem with manifolds, and especially when you've got a lot of weight hanging off say a 4-cylinder manifold and it's hanging out the side. You really don't want a brittle casting. We are starting to see, obviously, different materials come in. We print a lot of prototypes and try them. Often it's obviously that area is growing, and it's always good. I think we've got 2 3D printers, all tuned slightly for different things, and then we also get a lot of 3D printing outside, and we're bringing more and more of that into the production arena. But at the moment, we're happy with aluminium. Because we develop them ourselves, we're able to, I always say about casting, with the casting, we do all the machining once, so we can go to the nth degree in terms of removing all the weight, because we do the machining once. It's not like machining from billet, where it becomes a sort of you could machine for 3 days and still be removing weight. Well, we do that on our patterns for the foundry. We end up with very lightweight products.
Well, we got a few questions here. If you'd like to, address them, I think it'd be cool.
Yeah.
We have one already we're looking at that came in real early, and it was wanting to know about, the servo motors and everything as far as the data and all the throttle area versus angle data of your products. I mean, do y'all help assist people with that kind of information?
Yeah, we can do. So, I showed you our throttle actuator before. So obviously we've now got experience. We're not an ECU supplier, so we don't know to the nth degree, but we've got experience of mapping these now. We tend to, I can give you the great example. So when we ran the electronic throttle on our race car for the first time, essentially we had a major problem that every time you hit a curb, your foot would start bouncing on the pedal. And what had happened, obviously we'd removed the cable from the system. So there was a long cable that went from the accelerator pedal to the back of the car. We removed that cable. We replaced it with a very short cable to it's actually an actuator, a throttle position sensor out of an Audi R8, which just had a spring in it. So basically it was just a spring. So every time you hit a bump, your foot went like this. And lots of discussion. Oh, you can drive around it. You could drive around it by driving slowly. So then we had to introduce some damping into the pedal to actually make the pedal feel like a mechanical pedal, oddly. But then what we found is we're then able to map the throttle. So you can then change the pedal position versus the actual throttle position. So we started off with 40 millimeters travel. It felt unresponsive at the bottom end. So we increased the throttle opening at the bottom end. And then it felt unresponsive at the top end as well. So we crammed that up. So we ended up with what felt more drivable than the original throttle body setup on mechanical, but with 10 degrees less pedal travel. An important aspect of that is, obviously in most cases on an engine, as you go through the rev range, I guess the last probably 30 degrees of throttle makes the least difference. So what you're able to do on electronic throttle is basically make that happen very fast. So you actually get more reward from that last bit of the pedal. But yeah, we can always help customers out with that. In the end, for us, it was a bit of trial and error. It wasn't, we started off with a linear relationship between pedal position and throttle position. And now we've ended up with more of a, hard to explain here, but more of a curve. So it's gentle at the bottom end, but then it opens very quickly at the top end. And I guess,
well, I mean, you're trying to explain it just from a driver's feel. You know, if you don't know what's going on, if you can't feel it,
yeah,
it's hard to know, you know, to not be jumping wide open, or, you know, where you need to be with your foot. I mean, and to me, that's
interesting
part that you got to have from the driver to make all this kind of come together. Yeah. Right.
So that's the pedal feel is the biggest aspect of that. So the first time I drove this car, as I said, the bouncy pedal is horrible. Get rid of this. I don't like it. But as soon as we got the pedal feel similar, then even with a straight linear relationship we started with, it felt okay. And then once you tuned it a bit, now you wouldn't, you know, I could put anyone in the car and they wouldn't have a clue it's electronic throttle until, of course, they downshifted and it blipped for them.
That's pretty wild. Victor Franco Sr. wanted to know from Jenvey's perspective, and this is a lot about, I think, what we've been talking about here and earlier, in considering the benefits of length tuning. Where does the market, racing as well as road, stand regarding implementation of variable geometry induction systems in the future? And I think you just kind of, like you've been talking all around it and about it, is it kind of goes together all in the package. You know, you got to get it tuned to your wants, your needs.
Yeah. So I mean, obviously we're aware a lot of Formula One and some other series run or have run variable tuned intake. So you change the length of the system as it goes, as you change revs. So it keeps you it moves your peak torque as you go up the rev range. And we've actually done some work on motorbikes where they have a kind of a 2 position. So you have a set of an air horn and you drop another air horn in to change the length. That's a 2 position system. I think it's going to be a challenge. It's a mechanical challenge to do that. We're actually trying to do it on the race car, and it'll use one of our standard throttle actuators. It's a bit off yet, but some of the challenges, it's obviously the rev rate, the revs increase through the first, say, 3 or 4 gears is so quick that the benefits, maybe marginal, but once you get into the taller gears, I think it's a good gain. I think there's a lot of getting the basic length right and the basic sizing right and the injector position right and the butterfly sizing right is the important bit. And then this is your last, 1, 2, 3% that you're trying to get at the end.
Well, it sounds to me, my friend, you have definitely got this thing going in the right direction. So what's coming up next? I mean, have you got some races getting ready to happen, or you got some more testing on track testing or anything like that? Because I know you're going 24 hours a day, probably inside your own shop.
Yeah, well, we're racing again this weekend, so that'll be fun. But no, we're doing lots of things. We're working on now a fully profiled system, so the butterfly is in an aerodynamic shape. But we're also doing a lot more with the electronic throttle side. That for us is getting bigger and bigger now.
Well, I have found this very fascinating, and I really appreciate your time, and good luck with your future success, which I'm sure is going to be coming even more so around the corner here after all the folks listening today. But again, it's been a pleasure having you here on Epartrade and our locally webinar.
Perfect. Thank you very much. And thank you to everyone for listening in.
Thank you, Mike. Great session. And please send my best to your team. I was fortunate enough to visit Mike and Jenvey a few years ago with the late John Kilroy, and it's a wonderful business. And Mike is what this industry is all about, a racer, an entrepreneur, innovator. So thank you, Mike. This webinar has been recorded. It will be posted later on the Epartrade platform, distributed through our newsletter, social media channels. We push Jenvey's product back on the homepage of the Epartrade, so please visit epartrade.com for more information and updates. Next webinar will be on CNC plasma table. In the meantime, thank you and goodbye.
Epartrade is a digital platform that we've created basically to make life easier in the business community of auto racing.
Epartrade, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
Epartrade really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
Where will you find Farea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Farea Racing Components. Stand with us or race against us.